All right, this is number 16 on page 238, lesson 4-6. It's called a growing sand pile. Sand falls from a conveyor belt at the rate of 10 cubic meters per minute onto the top of a conical pile. So let's draw a picture. Got a pile that looks like a cone. And the sand's dropping onto that at 10 cubic meters per minute. So what do you think the label would be for that? The change in volume, so what would it be?
dV over dt.
Right, the change in volume over change in time, so it'd be dV over dt. And is the pile getting, if the pile's getting bigger, it's positive 10. If the pile's getting smaller, if we're taking sand off the pile, it would be negative. In this case, we're adding sand to the pile, so it's going to be positive. The change in volume is 10 cubic meters per minute. All right, here's the rest of the problem. The height of the pile is always 3/8 of the base diameter. How fast are the A, height, and B, radius changing when the pile is 4 meters high? Give your answer in centimeters per minute. So the height is always 3/8 of the diameter. So I'm going to write that out. The height is, or equals, 3/8 of the diameter. Now, we could change that to height equals 3/8. Diameter is all the way across the circle, right? The radius, you take 2 radii to make 1 diameter. So you can plug in, for the diameter, you can plug in 2 radii, 2r. 2 times 3/8, that's 6/8, or 3/4. So we end up with h, the height equals 3/4 of the radius. Any questions about that? Okay. So our height is this distance here, all the way to the tip. The radius is this distance. It's going to be a right angle there. We're talking about the volume of a cone, so we want to start with the volume of a cone as our beginning equation. Volume of a cone is 1/3 pi r squared h. And we're going to want to take the derivative on both sides because we want to talk about, we want to think about how fast the volume is changing. We want to think about how fast the radius is changing and how fast the height is changing when the height is 4 meters. Before we do the derivative on both sides, we need to get the right side of the equation to only have one variable in it. Right now we have r's and h's. So what could I plug in for h? 3/4 r, right? So you're going to have volume, I'm plugging 3/4 r in for h up here. So volume equals 1/3 pi r squared times 3/4 h, or 3/4 r, excuse me. Plug 3/4 r in for h right there. Let's simplify. I can take 1/3 times 3/4. That'd be 3/12 or 1/4 pi. And then r squared times r is r to the 3rd. So one thing to make sure you always do is make sure you get the equation simplified so you only have one variable on the left and one variable on the right before you take the derivative. Pi is not a variable, remember that's a constant. Now we're going to take the derivative. So the derivative of v would be, with respect to time, would be dv over dt. Here the derivative, you take 3 times 1/4 pi and you get 3/4 pi. Make your exponent 1 smaller, so r squared. And don't forget, by the chain rule, you have to multiply by the derivative of r, so dr over dt. Any questions about that? Okay. Now let's go back and see what they told us. Well, we know they told us that dv dt was 10 cubic meters per minute. So we're going to plug that in right here. So you're going to have 10 equals 3/4 pi times. Now they also gave us another number. They told us that they want to know how fast the height and radius are changing when the pile's 4 meters high. So our one instant they want us to think about is when h is 4. Well, we don't have h, so we don't want to plug 4 in for r. We need to figure out what r would be. So if h equals 3/4 r, then where would I plug the 4 in down here? Yeah, you put a 4 in for h. So let's do that up here. Instead of scratch work, 4 equals 3/4 r. So just multiply both sides by 4/3. So you get 12/12 or 1r equals 16/3. 4 times 4 would be 16/3. That's the number I need to plug in for r right there. So we're going to times by 16/3, and that's quantity squared times dr over dt. dr over dt would be how fast the radius is changing when the pile is exactly 4 meters high. That's what we're going to try to solve for. So we're going to solve for dr dt. I'm going to bring this up so you can see a little better. So I'm going to have 10 equals, let's see, 3/4 pi. I square 16, and you know, 16 times 16 is 256. 3 times 3 is 9, so you get 256 over 9. And dr over dt. 3 times 256 is like 768, I think. Over 4 times 9 is 36 pi times dr over dt. You check that, see if that's right. Okay. So now what would you do next?
Multiply by 36 over 7.
Okay. If you could multiply by the reciprocal, and then you could divide by pi on both sides. Okay. Or another option would you just take 10 divided by this whole constant, whatever that is, divided by 768 over 36 times pi. That's going to give you your dr over dt. So if we type that in our calculator, type that in for me quick. Make sure you put parentheses around the denominator so you divide by that whole amount. And this will be in meters per minute. Change in radius will be in meters, change in time will be in minutes.
1.492.
1.492 meters per minute. But they want us to give our answer in centimeters per minute. So, you know, there's 100 cents in a dollar, 100 centuries in a year, 100 centimeters in a meter. So if I just multiply by 100, which just moves the decimal 2 to the right, I would get 149.2 centimeters per minute.
It's 0.1492.
0.1492, that sounds better, okay. Move your 2 decimal 2 to the right, so it'll be 14.92 centimeters per minute. So when this pile is exactly 4 meters high, and sand's coming on at 10 cubic meters per minute, the radius at that one moment in time is getting bigger at 14.92 centimeters every minute. Okay. Now they also want to know how fast let's make sure that's which answer that is. Let's see. That's actually part B. We found B first. How fast the radius is changing. So this whole thing was part B. Part A wants to know how fast the height is changing. So go back to your equation that relates h and r. H equals 3/4 r. And just do the derivative on both sides with respect to time. So the derivative of h would be dh over dt. Derivative of 3/4 r would be 3/4 times dr over dt. And let's go ahead and use the answer that's already in centimeters per minute. That way we'll get centimeters per minute and won't have to do a conversion again. So put 14.92 in for dr dt. So dh dt, which is the change in height over the change in time, equals 3/4 times 14.92 centimeters per minute. So can you tell me what you get if you take 3/4 times 14.92?
11.92.
11.19. And again, now this is the change in height, so it would be centimeters per minute. We don't have to convert to centimeters per minute because I use the centimeters per minute number here, so that means I get centimeters per minute down here. So the height, when this is exactly 4 meters tall, the height is increasing at 11.19 centimeters per